What did you do wrong? Would you like to list chronologically or alphabetically? Oh, Luke. All right. So we're just going to do this very first example. And it starts off by saying, given a function s is equal to f of t, where s is distance and t is time, define the following. Position function is s equals f of t. I don't know. So I don't know why they use the variable s, but really it means that the position is a function of time. So if you plug in a certain time into the function, it will give you an output. The output tells you where you're located. All right. Velocity. Velocity is all about a rate. So in this situation, we have time, we have position. So position might be feet, time might be second. So velocity would be feet per second. So if it's a rate, how do we find velocity given the position function? We take the derivative. S prime is equal to f prime of t, or v of t. So velocity is the derivative of the position function. If a particle is at rest, what's the velocity of the function? Or velocity of the particle? It would be 0. So what we do is we take our velocity function, we set it equal to 0 to find out when the particle is at rest. Awesome. Particle moving in the positive direction, it means that the velocity is positive. So v of t is greater than 0. If you're looking at the graph, what does it mean for the graph to be greater than 0? Above the x-axis. Particle moving in the negative direction, that would mean v of t is less than 0, or below the x-axis. That leads us to example 1. A particle moves according to a law of motion, s is equal to f of t, where t greater than or equals 0, where t is measured in seconds and s is measured in feet. S of t is equal to t to the third minus 12t. So that's my position function. It tells me where I'm located at a given time. So just plug in a certain time, and you know where you're at. Find the velocity at time t. Let's write that expression right now. V of t would be equal to what? 3t squared minus 12, because velocity is the derivative of the position. What I'm going to do now is I'm going to sketch both of these graphs. This is my position function, and this is my velocity function. S of t, what is that graph going to look like? Yep, one of the whoop, whoop, whoop things, okay? It's a cubic. It will have 2 turns in it. And if we set it equal to 0, you can see that we get t times t squared minus 12. And so you have 3 solutions. One solution happens at 0. And then t squared minus 12, if you solve that equal to 0, you get what? Plus or minus the root of 12, or plus or minus 2 roots of 3. Square root of 12, right? If you find out what 2 roots of 3 is, it's about 3.4. So you have negative 3.4 and positive 3.4. So your graph looks something like that. So it's a guesstimate. Not exact. Okay. Let's ask some important questions here, okay? the velocity of the function. Okay, think about it. Right here, am I moving in the positive direction or the negative direction? Positive. Why? Because the slope is positive. But I'm below the x-axis, aren't I? But this is not the derivative, is it? This is not the velocity function. This is the position function. You can see that the slope is positive, so therefore I'm going in the positive direction. What happens here? So if velocity is 0, what does that mean? What is the particle doing? It's at rest. How about here? Moving in the negative direction. Yeah. Okay, so you can see what's happening with this, okay? Now, let's graph 3t squared minus 12. If we were to graph 0 equals 3t squared minus 12, or I set equal to 0, figure out how to graph it. So equals 3 times t squared minus 4. So 0 is equal to 3 times t plus 2 times t minus 2. Everybody agree? I'll change my tick marks here so that I have -2, -4, -6, -8, 10, 12. That way I've got a better... just see it better on the graph. So I'm going to plot -2 and +2, and this thing dips all the way down to 12. Which is my velocity function. Three t squared minus 12, so it's a parabola shifted down 12 units. All right. Positive direction or negative direction? I'm heading in the positive direction. Is the derivative... Okay, think about it, folks. Right here. Is the derivative positive or negative? The derivative is positive. This is the derivative, right? So don't draw a tangent line. Is this function right here positive or negative? It's positive, so therefore I'm headed in the positive direction. What happens here? It's at rest. It's equal to the velocity is 0 right here. How about here? How about here? Still negative. Not at rest. Still negative. Traveling at negative. It's traveling at -12 meters per second. This is traveling at -12 meters per second, or feet per second right here. Now it's traveling at -4 meters per second here, -6 meters per second. Here it's traveling at 0, so it's at rest. Here, positive. Okay? So you have to understand which graph gives you what. Now, you're not required for this assignment to sketch both graphs. However, it would help you probably to sketch them and understand what each is talking about. Let's now answer the questions. What is the velocity after 3 seconds? Let's plug it into the velocity function. V of 3 is 3 times 3 squared minus 12. Or 27 minus 12 is 15. Label it feet per second. When is the particle at rest? I would take the velocity function, v of t, equals 3t squared minus 12 and set it equal to 0. Factor out of 3, t squared minus 4 is equal to 0. T plus 2, t minus 2, so at what time? 2 and -2. Kind of interesting here. T equals -2 and +2 seconds. We don't talk about negative time. Okay, it's not of interest to us. So really, just 2 seconds is what we would quote. When is the particle moving in the positive direction? Well, 3t squared minus 12 greater than 0. You can't solve a quadratic inequality by adding and subtracting stuff over. Like some people would want to add the 12, divide by 3, square both sides. It doesn't work like that. If it's linear, if it's to the first power, go ahead and solve this just like you would. But as soon as this is a second degree, or if you have a rational one, you have one of two options. You either need to make a graph and look at the graph, or you got to do your interval testing thing. Remember when we did this? Remember when we did our interval testing? Positive, negative, negative, you know. Okay, that's how you solve inequalities. So you've got a choice here. I'm just trying to make my point, folks. What would you rather do? Set up the table or look at the graph? Just look at the graph, for crying out loud, you know? That's why we have it over there. It's why I did it right away. So you're wondering, where is this thing greater than 0? Well, it's above the x-axis from negative infinity to negative 2, which I'm not concerned about because that's negative time. But it's also greater than 0 from 2 to positive infinity. So that's when it's moving in the positive direction. Does that make sense? Okay. Is the graph above or below the x-axis here? So negative infinity to negative 2, because that's where it's above. From negative 2 to positive 2, it's below. And then from 2 to infinity, it's above again. Does that make sense? So find the total distance traveled during the first 8 seconds. First, we're going to do F, and that will tell us how to do E. We have to identify the beginning, the change. Yeah, you're going to have to find another space, like maybe right up top here. This might be a good spot right there. Or you can pull out a separate sheet of paper and attach it to it. Beginning, change, and the end. Okay, that's what we want to be able to identify. At what time do we begin? What's our beginning time? What do you think? When we start the clock, what's our beginning time? 0. So we want to find our position at 0. So we will find S of 0. When did we change direction? At negative 2 and positive 2. But we're not concerned about negative 2 because that's not in our time frame. So we changed direction S of 2, so I want to know where I am at 2. And then what's the end time? 8. I want to know over the course of 8 seconds. Okay? So if I want to know where I'm at those times, do I plug it into the velocity function or do I plug it into the position function? Position. So we do S of 0. 0 to the third minus 12 times 0. 0. So I start at 0. That's where it's starting. It's not always going to start at 0. Sometimes it'll start at 12, 20, negative 8. You don't know. I change direction at 2 seconds. Okay, let's see where I'm at 2. First of all, between 0 and 2, am I going to be traveling towards the right or the left? The positive direction or the negative direction? Negative, because the graph between 0 and 2 is below the x-axis. So you know it's going to the left. So when I plug in 2, should I come up with a negative number or a positive number? A negative, because it's traveling to the left. Let's plug in 2. What is 2 to the third? 8 minus 12 times 2? So negative 16. Now, from 2 to 8, am I traveling in the positive direction or negative direction? Positive. So I should, we don't know whether the answer will be positive or negative, but it should be greater than negative 16, because now I'm traveling back to the right. So we'll see what happens here. S of 8. Let's plug in 8. 416. So here's what happens, okay? I'm going to draw a picture to model, or a diagram to model the motion. I start at 0, and that occurs at time 0. Then I go back to negative 16. At what time does that occur? And then I go over to 416. At what time does that occur? Real quick before you go, it starts here, it travels back there, and then it ends right here. That's where we'll pick up. Yeah, that was the second bell. Yep. Okay, hopefully you guys had a good lunch. See, that's interesting over, like when people watch a YouTube video right now, like Ella, she watched a YouTube video from last year on related rates. She said, "Oh, you guys will get that's coming up, section 39." Okay. Anyway, so people are watching the video, they'll be like, "Oh wow, you guys got to go eat lunch." Maybe they pause their video at the same time and go eat lunch. Who knows? Maybe. Yeah. Maybe. Maybe. Yeah. I am too. Okay. They could probably have their lunch while they watch a video. Two birds with one stone. Okay. Find the total distance traveled. So after I've laid out these points, this is my beginning. This is my where I changed direction. Notice I was traveling the negative direction right away. That corresponds with the green portion of this graph. And then the blue portion remaining corresponds with then traveling the positive direction. That's what we have. So we know what's going on here. The question is, find the total distance traveled during the first 8 seconds. Well, in the first 2 seconds, how many units does it travel? 16 feet plus, and then after that, it goes from a negative 16 back to 0, which is 16, and then it goes from 0 to 416, which is 416. So if you add all those up, you get 448 feet. Now, it's 416 feet from its beginning position, but it's not asking about its displacement. Displacement would be 416. It's actually traveled. I mean, if it had an odometer, it would be 448. Okay, see that? Now, I would like you guys to start working on some problems that I've printed the page off for you, but they're polynomials. Tomorrow, we're going to look at, what happens when you got something like that. And that's a rational function. Yeah, we'll do it. But, okay. And so problems 1 through 4 is what we're going to do.